want to show you an example of a sublimation oven or a SubliPro oven. The one I'm showing here, the one that we're demonstrating today, is the largest of the three that we manufacture. We make a 24-inch belt, 36-inch belt, and a 48-inch belt. The 48-inch belt that you see behind me is 27 feet long, and it consists of a main body and a cooler. Let me show you the different components. On the right hand side is the entry part, the starting point, the loading part of the belt. Then the main body, you see the open control panel while it's been tested. On top is the exhaust. Below you see 4 motors, 4 air circulation motors that provide air circulation to the convection heaters. There's 20 convection heaters on the top side of the inside of this oven chamber. Behind that, at the exit side, you have first a cap, and then the mugs will travel under that cooler, which is ambient temperature flowing straight down onto the belt to cool any substrate before they're handled at the very end of the belt, unwrapped, unstrapped, and then packed right at the end. So loaded on the right, unpacked on the left. Let's look at the different components. This is the entry side or the loading side of the conveyor oven. You see how the conveyor oven moves in that direction. Mugs, later when I do the test, will be placed onto this belt and travel all the way, all 27 feet to the end of the oven. The lines that you see are guides to indicate where you can place the mugs, but they're also support for the heavy chain link stainless steel belt and for the weight of the substrates onto the belt. The curtains that you see are Teflon curtains, and they open and shut. They have the advantage of keeping the heat in while at the same time providing an easy entry and exit into and out of the oven. As we move along the oven, on top here, right underneath these panels, are the convection heaters. In case any of these heaters need to be replaced, these tops need to come off in order to replace the heaters that are located right underneath. The exhaust motor, exhausting the sublimation gases or other gases that generate during the sublimation process. The control panel, we'll come back to the control panel here in a minute. The exit side of the oven with a cap, an exhaust cap that will capture the last of the sublimation gases as the mugs exit the oven. You see a similar curtain, Teflon curtain, at the exit side, again, to maintain the heat inside the oven chamber and to provide easy entry and in this case exit of the mugs or any other substrate. The mugs then travel onward on the belt underneath this cooler and provide ambient directed air onto the belt through these air knives that are opened up at the bottom, above which powerful fans blow the air straight down onto the belt. Then here the exit side or the unloading side of the belt. So here another operator will stand and barehanded, because at this time the substrates are cooled down, will unload any mugs or any other substrate off the belt and pack them straight away after removing any kind of a wrap or strap or anything that the substrate has been attached to. let's go back to the control panel and explain a couple of things that are interesting about the control panel. First of all, here are the two temperature controllers, each one controlling one side of the oven. Right now, the temperature is set at 360 and the oven is right at 360 degrees. I will increase that for my test to about 395. See now, the current temperature is 360, the set temperature 395. I will wait to do the test until the current temperature equals the set temperature, and I will do the same on the second control. You see how the temperature is beginning to mount. As the temperature is mounting, you will see the heater indicator lights turn on. That means power is directed to the heaters, providing more heat to the inside of the oven chamber. The relays will stop the power from going to the heaters and will turn on as soon as the heaters turn off. You'll have two banks of heaters, 1 and 2, two banks of relays, 1 and 2, for both zones, zone 1 and zone 2. The heaters are now constantly on, providing more and more heat, and you see how the temperature is climbing to meet the 395 degrees set temperature. As they will approach the 395 set temperature, you will see the relays come on, off and on, in order to guide the temperature slowly but surely up to that set point of 395 without actually overshooting it. On this side, you have the belt speed controller. The belt speed controller is currently set to 14. That is 14 minutes, 0 seconds, and that is the travel time or the dwell time of any substrate that travels on the belt from the entry side of the oven to the exit side of the oven. Only the oven part. So only up to here and from right here, starting point of the oven. So from there to there, travel time is exactly 14 minutes, or the dwell time of the mugs in the oven. Right here are the airspeed controls. The airspeed right now is set to 0. I will keep it to 0 so the oven more easily can reach its higher set temperature. As soon as that temperature is reached, I will turn the airspeed to testing airspeed, which is about 6 or 7 for proper air circulation inside the oven chamber. Other than that, we have a couple of circuit breakers for the blowers, 4 blowers underneath, circuit breakers for the exhaust fan, and a circuit breaker for the exhaust motor, which is located at the very end of the oven. The on-off switch, the main on-off switch on the right-hand side, there's a cooler fan, an important cooler fan here, which keeps the inside of the control panel cool enough so that any of these sensitive controllers and controls and other electronic gadgets do not overheat because of the nearby high temperature of the oven. This shell is ambient cool, ambient hot. So it's not too hot, it's not 400 degrees as on the inside of the oven. And as you see, I can easily place my hand on the outside of the shell of the oven because air will pull in from the side and keep the outer shell cool in order to provide not too much heat to the outside and to the workspace and the outside of the oven. You see, in the meantime, how the temperature has moved up. It will now stabilize at around 395. You see how the relays and the heaters alternate in order to fine-tune the heat right at the 395. We're almost there. So at this point, I'm going to set the airspeed to 7. Which provides the air circulation inside the oven chamber, which is what I need to create an even temperature throughout the oven chamber between the left and the right side of the belt, between top and bottom of the heater of the oven chamber, between the front and the back, so that nowhere, no given point inside the oven is more than 10 degrees off any other point inside the oven. Everything is within plus or minus 5 degrees Fahrenheit. We're there, so let's start with the test. For my test, I have prepared 5 mugs. And I'll demonstrate how these mugs work together with the mug wraps that go inside with the oven, that work in conjunction with the oven. You see a blank mug. Around the blank mug I have taped a transfer, a sublimation transfer, and taped it snugly around the mug. What then happens is the mug wrap will fit comfortably around the mug and the transfer and provide a firm grip. Now, I'm using a little bit of sublimation blowout paper in order to avoid that any sublimation gases touch the handle of the mug, so that the mug handle doesn't become discolored. So I do this, cover it up, and then close my mug shut. I now close the mug, wrap, and as you see, 2 clicks in order to be able to fully provide all pressure needed for the mug. I'm now going to fill the oven. It's going to roll. I space the mugs out evenly. I only have 5 mugs here. I'm using, these 2 are 11-ounce mugs, but the other I've used 15-ounce mugs, same mug wrap. So you will see now, as the mugs enter the oven, you will see how the curtain will open up and allow the mugs to enter without any heat escaping. Right here, my temperature is virtually the same as right here, so not much heat escaping out of the oven thanks to the curtains that provide that barrier. As the mugs enter the oven, the heaters will automatically adjust. They will sense that a cold object or cold objects are moving into the oven chamber and therefore need to provide more heat in order to heat up the cool objects that just traveled inside the oven chamber. So you see the heat cycling on and off to maintain that 395 temperature even while the cold mugs are entering the oven. Again, the travel time is 14 minutes, so it will take 14 minutes for the mugs, from the time the mugs enter that curtain to the time that the mugs exit the curtain at the other end. We'll now skip these 14 minutes and we'll take you to the exit side of the mug oven. Okay, as you see, the mugs are now coming out of the oven. The Teflon curtains open again, allowing the mugs to travel out of the oven without loss of too much of heat. You can easily hold my hand here. Now the wraps, especially the belt buckles, the steel buckles, are 400 degrees hot now, so I don't want to touch them. At least not barehanded. I can do it with a glove, or I can just wait and safely let the mugs travel underneath the cooler, so that by the time they exit the cooler section, I can undo the wraps with my bare hand. We're at the end of the cycle now. The mugs come out from underneath the cooling tower, and they're now cool to the touch. Not completely cold, but cool to the touch. So no gloves are needed to unwrap the mug wraps and the mugs from the mug wraps, and then to continue packing the mugs and recycling the mug wraps, as I will demonstrate.